Okay, when working with some of these examples from today's classwork, let's look at number 15. I forget the page number, but it's asked us to simplify, and it is 7 cube root of x squared minus 2 cube root of x squared. And you can look at these at two ways. We have like radicals. So since we have like radicals, we can then add together the coefficients or combine the coefficients. So we are going to have, this is going to end up equaling the cube root of x squared because that's our radical, our like radicals. And then we have 7 minus 2, or we have 5, the cube root of x squared, and then that is as simplified as we can get it. All right, looking at number 21, when we go to combine these to simplify, we do not have like radicals right now. We have the cubed root of 81 and we have the cubed root of 54. But we know that both 81 and 54 are composite numbers. So since they're composite, we want to go ahead and break these radicals down to their prime factors and see what we can do from there. And when we're breaking it down, we do want to be intentional. Since we're looking for cubed roots, we want to be intentional when we're breaking it down. We want to look for cube factors. So when we do that, I know that I'm going to have 3 times the cubed root of, 81 is going to be 3 to the 4th power, or 3 cubed times 3. And I know then, and I'm going to have minus 2, and we'll break this cube root down. So the cube root of 54 is going to be, is that the cubed root, which is 27 times 2? So I believe then that we can simplify some more. And just to show you all the steps, I have 3 times the cubed root of 3 cubed times the cubed root of 3 minus 2 cubed root of, let's go ahead and shorten that up some. The cubed root of 3 cubed times the cubed root of 2. All right, so we know here now as we do some of our math operations, we should be able to see here that the cubed root, we should be able to see here that the cubed roots are going to end up giving me, canceling that out, so we get 3 times 3 times the cubed root of 3 minus 2, and of course times 3 times the cubed root of 2, and then further simplifying that, we're just going to combine like terms and work it out. So we know that we get 9 times the cubed root of 3 minus 6 times the cubed root of 2, and there we go. That problem has been now simplified. We have prime radicals that we have simplified and can do nothing more with. And our next example here for number 32, it is asking us to multiply these pairs of conjugate. So when I do this, I'm going to end up multiplying 3 times that binomial, or square root of 3, and then the square root of 5 times that binomial, and I'm going to FOIL it out, use whatever method you like, and see what happens. So when I use my distributive property, I can rewrite this as the cubed root of, square root of 3 times the square root of 3 minus the square root of 5, plus the square root of 5 times the square root of 3 minus the square root of 5. And now when I do my distributive property, I have the square root of 3 times the square root of 3 minus the square root of 3 times the square root of 5, plus the square root of 3 times the square root of 5 minus the square root of 5 times the square root of 5. And when we simplify these, this we should see as becoming the square root of 9, and the square root of 9 is going to be 3. This is going to be a positive square root of 15, and this is going to be minus a square root of 15. So those two things are going to become 0, right? We have the square root of 15 minus the square root of 15, which gives me 0. And then the next expression is going to be minus, because we have this minus sign. The square root of 5 times the square root of 5 is the square root of 25, which we know as 5. So therefore, my answer is going to be negative 2. 3 minus 5 is going to give me negative 2. And that's just a few examples when working with these binomials as we are working through these today.